Okay, so we're going to finish off where we left off right before the lunch. And I know it was such a long time ago. Hopefully you remember what we were talking about. I was getting into these keys, the primary, the foreign, the candidate keys. And remember before lunch we were having a problem saving files and opening up files. So let me show you what I mean by that. I was working with Safari, the dreaded Safari web browser. And it wasn't working for me. I couldn't figure out how in the world to save and retrieve, and it just was not working. So I've tried both Firefox and Chrome. They both work a lot better. Don't use Safari, bottom line. So I'm now back in, and I'm using Chrome this time. And if I use Chrome, I'll just demonstrate it real quick here. Standalone, same as before. And then I'm going to go into diagram. I'm going to say new ERD diagram. In a few minutes, we're actually going to look at the new relational schema in a few minutes as well. But new ERD diagram. I put an entity out here as an example. Let's throw another entity. And I'm just going to throw some stuff out here. I'll throw an attribute. I'm not really doing anything. I'm just going to throw some bunch of stuff out here. And then if I come over here to diagrams again and I say save diagram, see down here on the bottom, it looks like it's saving it this time. Down in the bottom of the screen, it says ERD plus is the extension, and because I had one, it was called Untitled. It now says Untitled 1, and I can find these actually in my folder here. If you're on the Windows machine, it's going to look a little bit differently. Where is this one? This one is probably going to be in Documents, or is it maybe Downloads? Probably Downloads. Yep, it's in Downloads. It's because it's coming from my web browser. On my computer, it's going into Downloads. So if you have your downloads set on your browser to go to a different folder outside of downloads, it'll show up in that folder. And so this is the file here that I just created. If I open it up into a text editor, it's not going to look that good. In fact, it might not even show at all. Do I have a text editor on here? I do. Here's one. It looks like this is what all that garbage I was looking at on the page. This is the code for it. It's not an image file. However, if you want, for the purposes of the homework assignment, to just give me this file, you can upload this file into Canvas and submit this file. And you can put, like, label it, like, and if you're going to label it, you're just going to do this, and you're going to go, like, assignment 1, number 1. There's 3 or 4 diagrams you have to do for, so 1, 2, 3. And then you can upload, because I know what program this is. It says the extension is ERD plus. I know which one it is. So what I would do then is copy it onto my folder. Then I would go, and let's say I want to open up this assignment 1-1. Then I would go back to my web browser. Whichever one I was on, probably Chrome. Here we go. And I could exit out of here. Actually, let's just go back in fresh. And then I could go to diagrams and I could say open diagram file. And then I'm going to open from the downloads folder assignment 1-1 that I just saved. Or maybe I downloaded it from Canvas because you turned it in. And I'm going to say open. And then, oh, I renamed the wrong one. It's the other one that I just did. So I could go here, open. This is the one actually I just did a few minutes ago. I renamed the wrong one. And now I'm back, so I can see yours. So you can give me an ERD plus diagram if you want, or you could export it. If you export it out using this, it looks like a little bit better as well. So if I export it and it looks like this, and I say save image, now I get an image file down here. It's a PNG file. So I actually get a PNG file. I'll take either one. You want to do an image? Do an image. You want to do the file? Send the file. That's how you're going to submit assignment number 1 and assignment number 2, which I'm going to show you in a few minutes as we go through it. So, meanwhile, back at the ranch, we were talking about entity relationship diagramming. So I'm going to go back to the PowerPoint that I was on and pick up, and then we're going to go into more concepts. We're talking about keys. Now, each one of the tables, or each one of the entities, and an entity is a table, by the way, has a structure to it for which we can create these keys. The keys are what's going to link the tables together.
So let me show you an example here, and I'm going to go back to ERD plus. I'm going to start new. Actually, excuse me. Let me go back to brand new slate here. So remember when I hit the diagram menu, I started with new ER diagram. I figured out how to put them all together in more than one-to-one if you want to. Right now you could just work with a binary one-to-one relationship. If you do that, then you're doing one-to-one with a relationship in between, and then you can string them together. It's a more reliable way of doing it. If you wanted to do the 3 or 4 together with the diamond, you can do it by hand, or you can actually do it using the star schema if you'd like. That also works. But let me show you how the keys work, and I'm going to demonstrate using the university database or university system that we were talking about this morning. So now I'm selecting option number 2. It says new relational schema. I'm going to give you a different version of this entity relationship diagram. This one's going to look like a database table. When I select this option, I don't have the tools anymore for an entity and a relationship and an attribute anymore. Instead, I get this. I get a table. That's about it. And I get a connection. That's about it. So I'm going to build the same entity relationship diagram without the entity relationship diagram. So back in the beginning when we were looking at this, we built this thing here, and I'm going to sort of build it here again. But now what I'm doing is I'm going to the translation part of it. Back when we created an entity, and we create the relationship, and we create another entity, and we put all that stuff together. Well, what we're really doing is creating tables. The entity turns into a table. And the relationship, if it's one-to-many or many-to-many, turns into a table. If it's a one-to-one, does not turn into a table. We'll do the full translation, but I'm just giving you the big picture. If we were to visualize the students taking classes and the teachers teaching the students and the classes being in rooms and that scenario, a very simple scenario, you could probably remember what the scenario was, I would hope. I'm going to map it out here using keys and stuff. So if I call this table over here students, remember students, and we gave some students some attributes. The attributes are actually columns. So I took and I clicked on table, and then I clicked on the canvas, and I stuck in here a name. So this one's going to be students are going to take classes. So we have a students and classes. It could be singular. You can say student and class over here if you wanted to. But what I've done is I've created, they're still entities, but they don't look like entities. They're tables. Because we've switched over into the table view instead of the entity relationship diagram view. And now you notice I can't put a relationship in the middle. So the relationship only tells the designer that you got to do keys. So I'm going to translate that relationship into the table structure. And it sort of looks like this. So a lot of people like to do the ERDs for design because you don't have to think at all about any of the database structure. And then you take that ERD and you translate it into a set of tables. Now, a lot of people would do this with it. They go like this, and they list up the tables this way. I'm going to list these tables out as if this were an entity relationship diagram. Instead, when I'm listing it out, I'm actually going to put the attributes, instead of there being bubbles showing the attributes, I'm going to put the attributes in the table. If I do that, I'm going to put them in what's called columns. So if I create a column as an example, I pressed on the column button, I'm in class right here. This is going to be the code, class code. And the class code is going to be like MSCS 100 something or 3200 something. It's the number of the code. And this interface is a little interesting. We're not going to click unique or optional on this. I'm just going to leave it alone. If I wanted to, I could press on what's called a primary key, and then I could select this, which is what I'm going to do. But I want to go backwards a little bit here. Well, here I'll select it right now because I know this is going to be the primary key. I'm going to press done. And now I see a little underline.
I'm just going to add some more items. I'm going to press primary key again in a few minutes. I'll show you what I'm talking about because we can switch it. So I'm going to add columns. Columns are attributes. So all those little bubbles that were hanging out on the entity are now going inside of the entity box. And they're going to turn into what we're going to call columns. It's like a spreadsheet. Actually, I think I have Excel on this computer. If you visualize it like a Microsoft Excel program, let's just do this one here. There we go. Remember Excel, you have, these are columns. And if I were to do a column in an Excel spreadsheet and I were to make it look like a database, it'd look like this. This would be code. This would be name. This would might be room. Maybe even instructor. Here, we'll put teacher here. And then we'd have all these classes like MSCS 100. I'm just making up some class codes. I don't think this one really exists. And the name of this class is going to be basket weaving. Now let's call this C programming. And then it's going to be in room, I don't know, 100. And the teacher is going to be Ghana, let's say. And then we have another class, MSCS, I don't know, 200. And then I'm going to call this Java for dummies. And this is going to be in room 200, and that's going to be me. I'll put my name. That's going to be Barbara. And so you see we have like rows. These are rows. These are columns. The same terminology you see in a spreadsheet applies in a database table. Rows and columns. Any number of rows, fixed number of columns. That's relational. That's what a relational database table is defined by. In Excel, however, we go and we say E3. And then we know what order we put the data in. In a database table, there is no order. It doesn't matter. We don't know. We don't care what order the database table is in. It doesn't matter. So in this particular case, when we store, we don't know which one is first, which one is second. So this is what we're creating in the relational schema, going from the entity to translate it into a table. So back in the database world, I'm going to add some columns for the class, the same ones I added a few minutes ago. I'm going to say there's a name to this one. And then the interface is weird. There's like no add button or commit or anything. You just have to keep hitting the add column again. So I'm going to say room, add, teacher. I can click on one of them if I wanted to, like this one here, and delete it, but I can't, like there's no other kind of way. So the name of this entity table is called class, and that's what shows up out here. And the columns themselves, if I click on primary key now I can switch the primary key if I wanted to. Or I can have, this is kind of deceiving, you only want one primary key per table. This one I actually do want it to be the code. But it doesn't necessarily have to be the first one. It could be like the second one or the third one. I mean, I can change the order. Here's what I'm talking about. Like I can move this one down as an example, and see how it moved down here. So if I look at it now, it's down one. It doesn't have to be the first item. It could be any item. So if this class code is a primary key, which I've designated it as being in this particular case, it means this is the one piece of information that's going to uniquely identify all of the other pieces of information, and every single one of the rows can be uniquely identified by this key. All classes have a unique class code. If I wanted the room to be unique, we can't share it. If I click on room, I could click on what's down here. It's called unique. Unique sticks in this little thing that says there's a U. You can probably see a small baby little U in there. Means it's unique. Means that you can't have two classes in the same room, or you can't use the room for more than one class. It's kind of a restriction we're going to put on the database. Or if you also want to make this one room, let's say the teacher. Maybe we have some classes where the teacher is optional. I can click on the optional. And the optional puts a little O in here in the diagram. That means maybe some of the teachers are online. Well, actually, we have online teachers. I don't know. Maybe The teacher component is optional. Like before, when a schedule is made, we don't necessarily have to have a teacher, but eventually we'll put a teacher in there, which means we don't necessarily need the data at all times. So those are the only two in this particular tool, the only two choices you have in terms of creating. And these are typical. You'll have in some databases more options. And if that's the case, then you're gonna mark more things about it. But let's go back to the structure here. So if the class has students inside of them, and then we have, I'm going to put another table in the middle here actually. I'm going to call this one registrations. Register, because students register for classes. And if I write this kind of like, because we just went through all this database entity relationship diagramming, I'm going to kind of make a table structure that looks like an entity relationship diagram. I want to show you why we're doing the ERD stuff. So students, I'm going to pretend like this is a relationship. Registers, and this is what they're registering for, classes. And we can easily make an entity relationship diagram that looks like this, but I don't think I have to. This would be like a diamond symbol normally. So for the student, I'm going to go back and add some stuff in here. I'm going to put the ID that we had in there. I'm going to put the name in there. I'm going to put the address in there. And what else am I going to put in there? Major. I'll put it here, a major. I'm just going to add some data in here to, I have name, I have ID, name, address, major. Oh, maybe date of birth. That's a good one too. Let's go date of birth. See how old the student is. Oh, probably GPA. I guess we can get carried away with this one. GPA. Lots of stuff we can say. Now I'm going to pick one. And the one I'm going to pick is going to be the primary key. So I'm going to select primary key, and I'm going to select ID. And then I'm going to press done. And see how ID is now bold and underlined in here. So I've got, I'm going to uniquely identify all my students by their ID. And in the registration database, we're going to have IDs with, probably with classes that they're going to take. And the way this is doing it, I'm going to do this totally backwards, by the way. I'm going to take, if you have a table that has a primary key, you can connect it through a relationship with another table. As an example, I'm going to click on the connect button here. I'm going to come over here and click on, oh, it's not going to let me. Yeah, here we go. Click on student. And I'm going to drag it to register. See how the red turned to green? I meant it was able to do it because this red here has a unique primary key in it. If I clicked on register and try to go backwards, it's not going to let me. Here we go, register. And I click on here, I got green. That's interesting, that shouldn't work. Oh, the ID is going to move over, so it's going to do it for me. Let's undo it. Undo. Now, technically, you want it to turn green. If it's not turning green, the connection can't be made. So, if I'm going to pretend like this is a relationship, the registers component, and if I have an ID, if I click on here to do the connect, hello, there we go. I'm going to connect it to this way. Then I get what's called a foreign key over in my connection table. And I see this arrow that goes this way. That means that ID is a primary key over here. Primary key is where it shows up first. It's primary. So it's first introduced in the student table. And students are registering for classes. I'm going back to entity relationship diagramming here. So I need to put something in here about the classes, so I need to connect this table to this table. So if I click on this one, oops, connect. Hello, and then connect it to here. I find if I press the mouse down and I push up or down a little bit, it actually grabs it. So now I have a code from here to here. So this foreign key is matched up this directory with the code, the course code, and then the ID arrow is going this way because it matches up with that ID. And the point I'm trying to make or illustrate here is that the relationship is tied together by the keys. And let me just save this sucker. Save the diagram. There we go. Now I have an untitled one. And if I just do it, you don't have to do this, but I'm just going to quickly toss this together so you can see what I'm talking about. This one here is takes or registers. I'm going to call it the same thing I did before. Registers. This is a class. And this is a student. And then we had our relationship here, student registers for classes. That's pretty much saying the same thing. Business people draw this out, and then you translate this. Because many students can take many classes, this relationship turns into a table, and we actually have 3 tables out of this. So I'm going to talk about cardinality for a second, because I skipped that in the earlier part. So it's all about the relationship. So sometimes the relationship will turn into a separate table, and sometimes it won't. In a few minutes, I'm going to show you something that doesn't turn into one. If I do the cardinality, and I was just doing this before the break, or during the break with you actually, another student in the class here, we noticed it's kind of backwards. We see the students, well, many students here, and then we looked over here and we went, many students, wait a minute. Well, the many is flying into classes, and the classes now have multiple, because on this side here it's a many. Many students are going into the classes. But in our case, it's both. It's many to many, so both of them get the many side. If students could only take one class, then we'd have one class. And if only one student could take one class, we'd have a one-to-one, which is this one single line that goes here. But they can take many students can take many classes. We have the many to many. Yeah.
So we click one in the right side. If the entity is student, actually the one will show up in the class side.
On the student end, I'm in the relationship itself, and I'm defining entity 1 with entity 2. Okay. And it's the relationship that entity 1 has with entity 2, it's determining it. So if I do 1 over here, I get it on the opposite. If students can only take one class, then I'm only going to have 1. Actually, this is a good way of putting it. This one has with this one, so you're really talking about this one. How many of these can they have? 1.
No, I mean, if you click in the class, entity class, if you click many, actually student will show many in the diagram, right? It's in the opposite way.
Many? It's opposite.
Yeah.
It looks opposite. It looks opposite, and this is what I was trying to explain. Because you're really counting, the cardinality is counting how many of these can have, and how many of these can have, how many of these can have, and how many of those can have. Students, how many classes can they take? Can they take one class, or can they take many classes? That's what it really means. It's the relationship that student has with classes. And then classes, do classes only have one student in them? Or do classes have many students in them? It looks backwards because of the way this tool is designed. I'm just letting you know ahead of time. I saw it, I looked at her computer and I went, what? Oh no, that's like messed up. Well, the other thing I don't like is anyway. There's a connection, I just haven't figured out how to make it. There's a connection that you can do with the 4. I just haven't figured it out yet, but we don't have to worry about it. Actually, nah, it's not going to work. Actually, let's see if I can make this work. It doesn't. It goes red to red. It's not going to go green. You know what I can probably do is an association, maybe? No.
It's doing, you know why? Because the connection button's putting the relationship in automatically for us. That's why. I figured the tool set out at least. The tool set's not going to allow us to go, we don't necessarily need to do it, but this tool set's not going to allow us to put the 4 together. You can do the 4 together, but it's not very common practice. It's actually more preferred to go 2 and 2. Yeah?
So in this website, it only give you advanced 2.
Yeah. If there is a way of doing it, I haven't quite figured it out yet. Which is interesting. It looks like now, if you can go like this, entity, and then connect, you can actually take this entity and connect it to another entity, and it'll put a relationship in there for you automatically. That's how that works. So at least we know that, but unfortunately, well, all you're going to do for this class is one-to-one anyway, so it doesn't really matter, but kind of weird. It's kind of weird that it doesn't. I probably, you know, over the weekend, before next time, I'll figure it out. Maybe you guys will figure it out first. But anyway, think about students, and it's how many classes can the students take, one or many of them. So that's basically how, and it looks completely backwards. I totally get that, actually. But this is the same thing as we looked at with, and let's just save this one now, and go back to the first one. Let's see if this works, actually. Here it is. So they all look the same. They're all titled the same. So when you get them out there in your downloads folder, rename them so they make a little bit more sense too. But this is really the same thing. Because it's a many-to-many, many students can take many classes. We have this relationship that's going this way. Let's not look at this. Let's look at another one, and I'll show you what I'm talking about. So if I go back to, let me save this one. Oops, it saves it again every time I save it. Let's go back to cancel. Let's open this one. No, that's not the one I wanted. Let's open, I think it's just called Untitled. This one. So remember, this one had many-to-many. This tool doesn't do it. However, there are some tools out there where you press a button and it creates the corresponding table diagram that we just looked at with all the connections on it, which is another form of the entity relationship diagram. So what you would normally do then is take the entity relationship diagram, translate it either by pressing a button or manually creating it, and put it into the other one, which is the table schematic. So the one of them is called an entity relationship diagram. The other one's called a relational schema. So let me show you something. I'm going to show you a one-to-one so that you can see. So this is one student. Let's just call this one a student here. And the student has a birth date. Only one student has one birth date. So I'm going to go here and say birth date. Birthday, and I'm going to connect them this way because now I learned this nifty little way of connecting them. And I have a relationship in the middle, and it's a one-to-one. So it's really a one-to-one. If you don't want to specify the cardinality and you leave it on the unspecified, you won't put any markers on the lines. But this one's a one-to-one. Which means in the student table, you're just going to add the birth date. You're not going to have the relationship table. There's no need to. So this is actually part of this one up here. So if I open up the, I don't need to save that one. I think it's this one actually. Open up this one. I can actually just add a column to this one and call it, oh, I did already. It's called date of birth. I don't necessarily need to add, here's the date of birth, I don't need to add anything in a relationship. I only need the relationship when I have the keys. And the relationship is essentially composed of all the keys plus any attributes. So if this is a register, there might be I can add attributes to this like day of the week. So time, maybe time, date or day. Maybe there's a teacher assigned to this registration, or maybe the class. Oh, the class has a teacher, so the class code would give me my teacher. So the idea in the terms of a good database design is I only have one piece of information in one table. And then you're going to say, well, wait a minute now, you have ID here, and you have ID here, and you have code over here now. Well, it's redundancy, but it's what they call controlled redundancy. It's controlled redundancy because now we're controlling where our duplicate data is, and we're only using the duplicate data to connect the tables together. So if I add another scenario like the room, the classes are conducted or held in rooms. If each class is only in one room, I don't have to make another table for it to show the relationship. If the class can be held in multiple rooms, then I could have a schedule, like a room schedule. And if that's the case, I'm going to create a table, and I'm going to stick it here. Oops, table. And this one's going to be called a room schedule, room assignment. Room assignments. And in here, I'm going to have a class code, or class, room number, room number, building, if it's in a different building or something, maybe address, I don't know, any information we want to store about it would go in here. And then if this was the room assignment and classes were assigned to rooms, I could connect this table with this table by clicking on connect and clicking on the room. And lo and behold, now I have room, and then I have code, class code is in here to determine which room. And then I'm looking at this room over here going, well, isn't that redundant? So I can actually make mistakes with this, which is why we do the entity relationship diagram first, then we translate it. Because this is jumping the gun a little bit in terms of our room assignments. Because then I could take this room and actually put it into a separate entity. Let me do that right now, actually. I'm going to call this one room. And the room has a number. Number has a capacity. And it has a, I don't know, type. Is it a lab room, or is it a lecture hall kind of room? And if that's the case, then I could probably get rid of this room here, or I could, you know, I can say here, well, let's connect these two together. So in terms of my connection, you're going to find a problem here where it's going to be red and red because I don't have a primary key. So you have to put a primary key in the table if it's going to lead to a link to another table. So if you're linking them together and you decide, okay, I know I have my attributes correct and my keys are correct, but I'm getting red and red. It's not coming back green. That means in here I probably want to create a primary key. I'm going to make the room number the primary key. If I do that, then on the room assignments, I'm going to go green. And then in here I'm going to get the number for the foreign key. So these items of the rooms are linking up in the room assignments. The room assignments are going to be for the classes. So the class code has a room number in it, which means I can have multiples. If I don't have multiples, I don't need all this. I wouldn't put this in unless I had many multiplicity going on. If I only had one room, then I would leave this one alone and just put room on here. Or better yet, I could take this table here and link it, connect it to this table here, and I would have them both linked together. That's kind of hairy. So most likely what I would do is just take this table out and then keep this one in here and say that this is, in fact, here, I'm going to make this a little bit more explanatory. I'm going to say room number. Room number. And then in here, the foreign key needs to be changed. Room number. Surprised it didn't change it for me automatically. And then I'm going to get rid of this room because we don't really need it. It's extra. So So if the class is only going to be in one room, we have the room number, and then we can keep all the stuff about the room in here. Maybe temperature, temperature in the room, the number, the capacity, anything you want to keep about the room. So these are the keys that are holding the tables together. This is a relational schema. Some people give this to developers. Some people give the entity relationship diagram to the developers. So it's half a dozen or another in terms of which one. Some people can't handle this part, or they don't want to do this part. If they don't want to do this, this is the finished product, by the way. This is your design. Some people don't want to do this because then you have to think about the business rules on the cardinality. Then we have this thing called participation as well that's not in here. So this is not considering participation. It isn't really considering cardinality. We're sort of reading it into the concept. So let me go back. I'm going to save this one actually. I have to figure out how to do a save as. You know what I'm going to do? I'm going to actually go in and manually do a save as by hitting downloads, getting rid of all the. I think this one here is the good one. You know, it doesn't really matter. I'm just going to get rid of all of them. Move to trash. There we go. You probably don't want to move them all.
So if we save as XML file.
Oh, you can?
No, but how to open this?
Oh, it's going to be a PNG file if you save as. Hold on a second. Let me open it back up again. I have to save this. So let me find out. So if I do a save diagram, then I'm going to get an XML file that I can open back up in here. Okay, so I just saved it. So let me show you. I'm going to exit back out and come back in. So I'm going to come back in fresh. And you can actually bookmark this. In fact, let me do that. Bookmark this page. Bookmark bar. There we go. So this one's going to lead me directly to here. And then I'm going to go diagram, open diagram file. And then, because I just cleared out my downloads folder, I see it right here. It's untitled.fact. I can't get to that here. I should be able to edit the name anyway, but open, and it brings it back. It's an XML file, but it will open back up. If I wanted to save as a picture, then I would export it out as a PNG, export image. And then, well, that looks pretty good. And then I would save image. And now I have it as an image file. If I open up here, I'm going to get it in preview on my Mac. A PNG file, if you do it as an image. If you don't do it as an image, you just save it, you get a ERD plus file. And that's an XML file, but if you load it back up into the tool, you see it. Which is why I'm saying I have the tools, so everybody has the tools free. So you can send, if you want to upload, let's say this was your finished assignment, number 1, part A. You could just submit this in the file form, in the XML form. Because I'll know what it is. Yeah? Let me see. Let me pause this for a second. Resume. Okay, back at the ranch. Now we got that solved. So you can turn this in, just the file itself, the XML file. That's fine. Okay, so let's go back to the lecture and see what else we need to do before we can move on to assignment number 1. So those are the keys I'm trying to demonstrate to you. The primary key. You don't necessarily need to worry about the composite keys at this point. We'll see those later in the course, but for day number 1 of a database class, it's a lot just to remember primary and foreign key and how they work together. This is an illustration of the diagram, very similar to what we just looked at a few minutes ago, except for these boxes. It's a different drawing tool, so these boxes have the lines that go across. Now you might notice there's this little manages and has over here. There's also a label. If you want to do it, there's also a label over here. Let me show you that real quick. In the drawing tool, so it says label. If you put the label here, you can say that this is, what is this one? This one, classes. Classes are held held in rooms. So I can take this label. Doesn't look like I can resize it too much, but I can stick it right here if I want to put the label on there. I don't believe this tool does not allow you to do anything with the, oops, it's covering up. Yeah, looks like underneath is your best option. It's not allowing you to put the little arrows in. You don't have to label everything, but people like to label it, and the label is available, just to let you know. But labeling something like that would be extremely optional, but that's why this slide looks a little different, because it has a line, so let me put a line here, but, and then the numbering is very similar, but they put the labels on the relationships. So we have strong entities and weak entities, and we have that in the drawing tool as well. Strong entity must exist. It exists with or without other entities. A weak entity only exists if the strong entity is there. So the classic example of this would be employees that work at a company. They're strong, they work at the company. And for the health insurance policy, employees can put dependents on the health insurance policy. Those are weak entities, because the dependents wouldn't be on the company health insurance policy if it weren't for the employee working for the company. So they're dependent on the existence of the employee at the company. Kids just can't go up to any company and say, hey, I want health insurance, because they're not going to get it unless their parent is actually working at the company. So in essence, the child entity on the health insurance policy would be the weak entity, and the employee would be the strong one. And here's an example of a client that has preferences set for a website or for a tool of some sort. They're not going to have any preferences if they just visited the site one time and they decided that they didn't want that, or something of that nature, which means essentially it's optional. So weak entities don't necessarily need to exist. They're just kind of there as a, because they're in the system. But they don't necessarily need to be part of the database. So in essence, for the understanding of the relational database and how it turns into the table format, it doesn't matter if they're weak or they're strong. But you can identify them in the diagramming. So I can come over here. Oops, I don't want to use that one. I think I'm in Chrome. I have to remember where I'm at. And, well, if I'm not in the entity relationship, but if I have I don't want to mess up this one. So if I were in the entity relationship, you see there's a one that says weak, and then there's another one. Actually, let me just, I think I have this one saved, actually. Let me just save it again. This one's number 1. So in my diagrams, if I open up, nope, I deleted all the other ones. I create a new ERD. I'll just show you what I'm talking about. Here's an entity where it says regular, weak, or associative. We're not going to do associative today, but if this were a weak entity, you see how there's a double ring around it? It needs to belong to a strong entity. So if I take another strong entity, stick it in here. And this one's a regular. So the tool calls it a regular versus a strong. But the weak entity could be connected to the strong entity. And then there would be, because it's one entity to another entity, the format is always one entity connected to another entity. And if it's defined as weak here, it looks different, which means this can't exist unless it has a relationship with the parent. So this would be the employee, and then this one would be the dependent, as an example. So there's a way of showing that in the diagram itself. So here's newspapers that are advertising properties for rent. So a newspaper with a newspaper name advertises property for rent with a property number. And then we have a date that the advertisement went out and a cost that's associated with it. That's part of the relationship. And I talked through this already, but let me give you just the terminology that I was talking about before lunch. Multiplicity. That's that movie, you know, where the guy clones himself. In this, it's called multiplicity. A lot of people don't like that word. The math word for it is cardinality, or degrees of belonging, or number of occurrences, number of So multiplicity range or number of possible occurrences is what that means. It represents the business rules of the company. As an example, if we have a bus and the bus only has 25 seats on it, we don't want to sell 27 seats because we can't put 27 people on the bus that only holds 25. Kind of like room scheduling, actually. This room only is supposed to hold 28 people. We don't have that many people in here, so it doesn't really matter. But you're establishing the business rule on the entity. You're specifying out something about its multiplicity. How many people, how many students can take classes in this room? 25 or 28. What do we got? We know about, and this is the terminology I've been talking about so far, the one-to-one, the one-to-many, the many-to-many. These are your relationship cardinality types or degrees of relationships. Common degrees of relationship is binary. This one is binary. And we have two numbers that we associate with this. Participation or no participation in terms of mandatory or optional. And then the number of. So in this particular case, we have a one-to-one. Don't have to worry about the syntax, but it says 1 dot dot 1, or you can go 1 colon 1. Or in our case, our design tool is putting a 1 here. And then it's putting crow's feet over here. A little easier to look at. In our relationship diagramming tool, however, we have both going on. If I were to look at the relationship here, and now I'm going to talk about this column here, it's called participation. If it's a mandatory participation, we see a 1. So the dependent has to be part of, which is not normally the case. Employees don't necessarily have to have a dependent on the health insurance policy. Employees can just themselves be on the insurance policy. So if that's the case, then it really should be optional. If you press optional, this is really a 0. It looks like a really weird bubble thing on the screen, but it's a 0 versus a mandatory, which gives you a 1. Same thing as the cardinality, it's backwards. I'm on the dependent side, which is over here, and stuff over here is getting changed. Because I'm going backwards. Dependents aren't required, it's optional. Well, actually it's not. They have to have at least 1 employee. Otherwise they can't be on there. But employees don't necessarily have to have dependents. This one's optional. So in order for these guys to be on the policy, there needs to be an employee. In order for the employee to be on the medical insurance policy, they don't need dependents. So when in doubt, just think it's really the opposite. If you set both participation and cardinality, then you get that dependents really only have 1. They really only have 1 employee. And unless both parents are working for the same company. And if that's the case, you have many. But let's just talk about 1 then. And then on this side here, employees could have many dependents. So I'm clicking the many here. And you see how I have two lines over here now. One of them's for participation, the other one is for cardinality. Cardinality is where here is the same thing as multiplicity, as we saw before. That, believe it or not, is anything and everything you ever needed to know about entity relationship diagramming. That's everything. Now, you're going to remember it? Probably not unless you practice it. So we have a couple of exercises you're going to do for assignment number 1. It's going to practice it. And assignment number 2, you're going to work with the other one. The relational schema is what you're going to work with. So let me see if there's anything else in the slide set that I haven't covered yet. And the slide set's going to go through all the different scenarios. Uses different syntax. Don't worry about the syntax at this point. We'll see it live again with some practice. But here's the 0 dot dot 1, meaning it's optional, and that every property for rent is overseen by 0 or 1 member of the staff, and each member of the staff oversees 0 or more properties for rents. So this is what this is meaning. So these are just examples. This is slide set number 3, lecture 3. Just examples of the different relationships. If if you can imagine one-to-many, one-to-many, none-to-many, one-to-one, many-to-many. If you were to put them together, we're not going to do this, but if you were to put them together with the 3 entities, you'd put them on all 3. So this is staff that registers clients at a branch. Well, sometimes there's no clients. That's why we have a 0 here. Now, we actually have to have a staff member, and we have to have a branch in order for this to work. So we're not going to put 0 here. We're just going to put 1 in here. But we definitely sometimes don't have any customers. So that's why that 0 makes sense. This is a summary of the multiplicity constraints here. The 0 or 1 entity occurrences, exactly only 1 entity occurrences, etc. and so forth. And the explanation of the cardinality and the participation one more time, just as a summary, just showing you by definition what it means. I'm kind of going through this a little bit fast because it's kind of dry at this point, but you can certainly download the slide set and go through it a little bit slower or at your own pace if you want. I'm not going to go through the problems with the ER diagrams right now because I don't want to complicate you with problems, but actually, let's go through the problems. Let's go through the problems just so we can get them out of the way. But don't get too afraid when you start looking at these problems. Problems come into two connection traps, where either the connection is ambiguous or the connection doesn't exist at all. And this is the connection between the entities I'm talking about that forms the relationships. And they're called fan or chasm traps. So the fan trap represents the relationship between the entities, but the pathway is uncertain. It's ambiguous. The other one just says it doesn't exist at all. There's no connection. Let me show you an example of one that's ambiguous. And it has to do with the order that you're putting the stuff into. So we have a staff person, and there's a division that has staff, and the division operates at a branch. This is what this is saying. All the words are left out, but the division has staff, and division operates at a branch. And so the question you have to ask yourself is, at which branch office does staff number SG37 work? Or better yet, at which branch do any of these staff work? We know there's a connection because the staff work at branches, but we don't know which staff are working. The staff are working at divisions, and the divisions are at the branches. But we don't know which staff is working at which branch. So we reorder the diagram, and it tells us which branch by taking the division to a branch, and the branch has the staff. We switch the orders of the entities around, so we could tell which one was at which one. That's why I keep moving the entities around on the screen. We're going to see that when we do assignment number 1, because you don't know what order. Depending upon the order, it makes logical sense or it doesn't make any logical sense. It's ambiguous. So you want to make sure if you can understand and answer all the questions about the information, and say, well, what branch do these people staff work at? Well, I'm not going to know that unless I connect the staff to the branch. Then I'm going to know. So we'll see. And then the other one is when there isn't a connection. So we know that here that SG37 works at branch 003. So here's the other one. The other one had an ambiguous connection. This one doesn't have a connection at all. This one has the branch that has staff, that has property for rent. And the question is, at which branch office is property PA14 available? So we have properties, and we have a branch, and we have staff. We know the staff are working at the branches, but we don't know which property, which branch the property for rent is listed at. And we get back there by making a connection between this one and this one. So we connect this one to this one, and then lo and behold, now we know. Because we have this one and this one connected. And you see this big circle going on here, you know everybody's connected. So you don't necessarily have to connect like this. But this one's going to tell us by adding the offers relationship, it resolves the trap. so that we know that the property for rent is being offered at this branch. Those are the two complicated scenarios you run into. Not too bad. Here's some symbol sets. The tool set that we're using is looking like this one. It's called the crow's feet. It might look familiar at this point. The boxes actually kind of look like this, though. This is the weak entity box. This is a strong entity box. I don't know. Our boxes are looking a little. Our weak entity boxes look like that, but we're using crow's feet. So these are the different tool sets. Unfortunately, this one I found here, this tool set is interesting. It's not using any one of them. It's actually using this one, but it's not using M for many. It's using the cross between the crow's foot and the chin. Because we have this kind of symbols going on. We have the crow's feet going on in our diagrams. Because we got this crow's feet going on. So it's a hybrid between these two different symbol sets. And there's no standard. These over here are not used very much, though. I'll tell you that. Crow's foot one is probably the most popular symbol set you'll see. Alright, let's look at assignment number 1. And I'm going to stop this recording and start fresh. So, let's see. Stop cap.